I want to talk about electric potential energy and electric potential. The two are related by this formula. Here is the electric potential energy. Q is the charge. It's a lowercase q, so we're including polarity. And phi here is the electric potential. And we commonly just call electric potential, just so you know. Now, we've talked about potential energy already. Potential energy, mgh. We've talked about spring potential energy, 1/2 k L squared. Now we've got electric potential energy, no big deal. But potential is something new to us. What is potential? Well, strictly speaking, it's the potential energy per unit charge. So what? Why do we care about that? Well, we're actually going to be moving away from energy. We're going to be moving to potential, using potential a lot. More specifically, we're going to be using potential difference, which we commonly refer to as voltage. And the reason we're doing that is because electric potential energy involves the charge and consequently the polarity. And that can lead to a lot of confusion. It turns out to be a lot simpler to just deal with the potential, which is independent of that charge. And the best way to show this is actually to take a look at this situation here. I've got two parallel plates. This plate is positively charged, this one's negatively charged. The red arrows are the electric field. And this is a capacitor. And if we talk about the electric potential energy, so if you're talking about a positive charge, let's say I've got a positive charge, and I'll put that positive charge put it right here. Okay. As the positive charge moves in the direction of the electric field, so if it moves up, as it moves in the direction of the electric field, its potential energy will decrease. But let's say I had a negative charge, and somehow it was moving in this direction, maybe because I'm literally pulling it down or pulling it up. It doesn't matter. If it's moving that way, its electric potential energy will actually increase because it's getting closer to these other negative charges, which, they repel each other. The negatives repel each other. So by moving it up closer to them, I'm increasing its potential energy. So that can be a little confusing. Contrast that with electric potential. In both cases, the electric potential for both the positive charge and the negative charge would decrease. The potential decreases in the direction of the E field. So as whether it's a positive charge or a negative charge, if it's moving in the direction of the electric field, its potential is decreasing. And I say its potential, it's the potential that it experiences, which is due to, in this case, due to these plates. It's not the potential it itself creates, it's the potential that it experiences from everything else that's around it. So you can see right there, that's a lot simpler. The electric potential decreases as I go from positive to negative. That's easier to deal with as opposed to when I'm dealing with the energy. I have to worry about the polarity of the actual charge I'm dealing with. And in fact, I can talk about the electric potential without even having a particle, without even having a charged particle. I can just say, oh yeah, the potential here is 10 volts, here it's 5 volts, here it's 3 volts, whatever. I can do that as opposed to with potential energy, I have to have an actual object so that I can talk about its potential energy. So these reasons, these are a big part of why we are going to be moving to talking about potential as opposed to potential energy.